All right, so today we're working on the division and rationalization of radicals. All right, let's look at a couple of basic guidelines for simplifying radicals. Basically, what we're working today is instead of multiplying numbers with radicals in them or adding them or subtracting them like we've all done before, now we're working with division, which means we're working with radicals and fractions. All right, don't panic. This is easier than it sounds. All right, number one, basic guidelines. The radicand should not contain a fraction. Get my pen up here to work. Should not contain a fraction. That means that if I see something like this, I've got a problem. The square root of 3/4. I can't have a fraction as my radicand, so I got to fix it. All right, so I split it apart to the square root of 3 over the square root of 4. Much the same as if I had the square root of 12. Remember, I could break this apart into things that multiplied. I could say that's also equal to the square root of 3 times the square root of 4. All right, that's all we're doing. We're just breaking this guy apart. All right, basic guideline number 2. There are no radicals in the denominator. So what that means is my solution up here, where I got rid of my fraction, radical 3 over radical 4, that's a problem. I'm not allowed to have this radical 4 down here. So how do I fix it? All right, the easiest way to fix it, when it works, is to simplify this. Does 4 have a square root? Yeah, totally does. So this, I can actually just simplify it to the square root of 3 over 2. All right, so that's going to be our very first step, is anytime we're simplifying, we have a radical in the bottom, we're going to see if we can simplify it first. All right, so let's look at our examples. First one I have is the square root of a to the 6th over b to the 4th. Yeah, okay, rule number 1. So no fractions in the radicand. So we have to split this apart. So it becomes the square root of a to the 6th over the square root of b to the 4th. Next step, let's see if we can simplify these, right? Well, okay, I'm just going to start with the numerator. What's the square root of a to the 6th? Well, a cubed, right? Denominator, what's the square root of b to the 4th? Well, b squared. Hey, that one worked out nicely for us. Let's see if we can do these others. Next one, cubed root of 81 y to the 5th over x to the 3rd. Once again, no fractions that are radicand, so let's split this sucker apart. Cubed root of 81 y to the 5th over the cubed root of x cubed. Very, very important. Do not forget your indexes here, okay? I see many, many students making mistakes. When they rewrite these things, they lose that 3, and then they're writing the square root of 81 instead of the cube root, and that's a big problem, okay? Don't do that. All right, next. Let's see if we can break this sucker apart. Well, the cubed root of x cubed, we know that one's x. And then the cubed root of y to the 5th, well, we know I'm going to have a y come out, and then a y squared stay in. Let's see about this 81. What can we do to break that down? Well, 81 is 9 times 9, and 9 is 3 times 3, and I need a group of 3 to come out, so looks like 3 comes out, and 3 stays in. All right, let's rewrite this to make it a little neater. So 3y times the square root of 3y squared, and remember it's the cubed root over x. All right, next, what do I do here? Any ideas? All right, we have the basics here. All right, next, rationalizing the denominator. What does it mean to rationalize? All right, this means we're going to get rid of the radical. When it doesn't simplify. All right, so first we're going to look at how do we do that when we're rationalizing the denominator when it has one term. So if our denominator is a monomial, mono meaning one, and we'll look at an example of how to do that. So when we have a monomial and it won't break down, it doesn't simplify. Let's look at 2 over radical 3. There is no square root of 3, right? We can't do anything about it. So we have to figure out a way to get rid of that radical on the bottom without changing the value of our fraction, okay? Fortunately for us, we have these wonderful things in math called equivalent fractions, right? So for example, 1/2 is equal to 2/4. Two different ways of saying the same thing. They're equal to each other, right? So we're going to use the same concept that we would use to go from 1/2 to 2/4 to change this 2 over radical 3 into a form that no longer has a radical on the bottom. So how do we do this? Well, when we changed from 1/2 to 2/4, we multiplied both the numerator and the denominator by the same number, right? So in this case, I multiplied both the numerator and the denominator by 2, okay? In essence, I multiplied the entire fraction times something that's equivalent to 1, right? 2 over 2 equals 1, just like 5 over 5 equals 1, a million over a million equals 1. I'm going to do the same thing here with my fraction with the radical on the bottom, all right? And what I'm going to do is I'm going to strategically choose what values I use for my numerator and my denominator so that I can eliminate this radical. So for this particular one, I'm going to choose radical 3. And remember, I want my numerator and denominator to be the same because it has to be equal to 1. If I multiply by anything except for 1, I change the value of my fraction. All right, so it has to be equal to 1. So then we multiply. So this equals 2 radical 3 over, what's radical 3 times radical 3? Well, if you think about it, it's radical 9. And what's the square root of 9? Well, it's 3. All right. So quick shortcut so you don't have to run it through 9 every time. Run it through the radical. Any radical times itself, the radicals cancel out. All right. Another way of saying this would be radical 3 squared, right? Radical 3 times radical 3 is radical 3 squared. And you can think that the radical and the squared cancel each other out. All right, let's look at the next one. This says the square root of radical 5, the square root of y to the 5th over 7. Once again, we know we can't have a fraction in our radical, inside our radicand. So this becomes the square root of y to the 5th over the square root of 7. 7 doesn't have a square root, all right? But we can't simplify this y to the 5th first. So it gives me y squared times radical y over radical 7. Once again, we're going to multiply it times the same thing on the numerator and the denominator. So y squared radical y over radical 7. We're going to multiply top and bottom times radical 7. All right, we're going to choose a radical on the bottom every single time. So this equals y squared times the square root of 7y over 7. All right. So I think you all see how that works. What do I do when I've got something like, we're just going to use over this one at the end, when I've got something like this? I have something inside my radical and I have something outside my radical in the denominator. Well, we could multiply by the entire denominator, but we don't need to. All right, let me show you. We are still going to choose just what the radical is here. All right, so times radical 3x over radical 3x. Let's do our multiplication. So this is 6xy radical 3x over 5. And remember, radical 3x times radical 3x gives me just 3x. And then I multiply my 5 times my 3. So 6xy radical 3x over 15x. And if we're paying attention, I've got an x outside here and an x outside here that can cancel. So let's fix this. So I now have, oh, also 3's, right? 3 goes into 6 twice, 3 goes into 15. 5 times. So I now have 2/5 y radical 3x over 5. So 2y radical 3x over 5 is my simplest form. All right. Always, 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 always double check and make sure that you have everything reduced, canceled out as far as it will go. All right. Check at the beginning, check at the end, check in the middle. All right. It's very much like when we're factoring. I tell you, look for a GCF always and forever. Look all the time. Same thing here. Make sure that you've got everything canceled out. You want these to be in as simple a terms as possible. So don't get so hung up on messing with the radicals that you miss something easy like this, that 6/15 is equal to 2/5. All right. All right. So next, rationalize the denominator when we have two terms. So if our denominator is a binomial. All right. So what do you do when you have one that looks like this? 3/3x minus radical 5. If I just multiply this times radical 5, I'm not getting rid of anything, right? Radical 5 over radical 5. It gets rid of the one here. Gives me 3 radical 5 over 3x minus 5. Sorry, 3x radical 5 minus 5. So I got rid of my radical here, but I just moved it over here. Yeah, not going to be successful. We need another method. All right, so what we need here is we need to use something called the conjugate. All right, which means the same number opposite middle sign. All right, what do I mean by this? Well, let's look at our examples here. All right, it's asking you what is the conjugate of x minus radical 2? All right, same numbers, x radical 2, change the middle sign. This is minus, so we're going to use plus. All right, this one, what is the conjugate of negative 2 plus radical x? Once again, same numbers, opposite middle sign. So this was plus, we're going to make it minus. All right, why do we want to use this? What is our advantage here? All right, remember we're going to multiply times the value that's equal to 1. So you want the same on the top as we do on the bottom, and we're trying to get rid of these radicals. So let me show you what happens when we multiply our original number. So x minus radical 2 times our conjugate. Watch this. So we're going to use FOIL first. So x times x is x squared outsides. X times positive radical 2, so plus x radical 2 insides negative radical 2 times x, so minus x radical 2, and last radical 2, negative radical 2 times radical 2 gives me minus 2. So what just happened here? Well, let's clean this up first. Let's combine our like terms. Well, I have a plus x radical 2 and a minus x radical 2. They cancel out. So all I'm left with here is x squared minus 2. Do you see what we did? By strategically picking what we multiplied these by, I was able to cancel out my radicals completely and leave myself with a denominator that has no radicals in it. All right, let's do a couple more examples. We got some examples down here. First, identify the conjugate. All right, you do not absolutely have to every single time write conjugate and write it down, but it's a good habit to get into. So the conjugate, same number, opposite sign. So we're going to multiply this times 2 minus radical 6. And what we do to the bottom, we want to do to the top because it still needs to be equal to 1. All right, so then let's multiply. Negative 2 times 2 is negative 4. Negative 2 times negative radical 6 is going to be plus 2 radical 6 over firsts. So this is going to be 4 outsides minus 2 radical 6 insides plus 2 radical 6 lasts minus 6. All right, this cancels out, leaving me with negative 4 plus 2 radical 6 over negative 2. All right, remember what I told you about making sure that we simplify this as much as possible. Well, I can take a negative 2 out of all 3 of these terms, right? So this is 2 minus radical 6 over 1. All right, let's look at one more thing with the conjugate. Let's look at our very last example here. All right, the conjugate again, and we've got radicals in the top and the bottom here, but it doesn't matter. We only are concerned about the denominator. So what is my conjugate of this? Well, it's the same numbers, opposite sign in the middle. All right, radical 2 plus radical 5. All right, and then I got to FOIL the top and I have to FOIL the bottom here. So let's start with the top. So first, 5 radical 6 outsides plus 5 radical 15 insides minus 2 radical 14 and lasts minus 2 radical 35. Okay, that's a lot to write. Not too bad though. All right, next, let's do the bottom. First, radical 2 times radical 2 is 2. Outsides becomes plus radical 10. Insides minus radical 10. And last, minus 5. Radical 10s cancel out. Can I do anything with the top? No, not really. Radical 6 is 3 times 2. They don't have a square root there. Square root of 15 is 3 times 5. No. 2 times 7. No. 3 times 7. Sorry, 5 times 7. Yeah, no. Okay, I can do nothing with that. So that has to stay. So let's rewrite and clean this up. So I have 5 times the square root of 6 plus 5 square root of 15 minus 2 square root of 14 minus 2 square roots of 35 over 2 minus 5, so negative 3. And that's it. As always, if you have any questions, be sure to send me an email, and good luck with your homework.